All right, we're still in our triangle congruency unit. We're looking at section 2, which is using 3 different forms of triangle congruency, or 3 different ways to prove that triangles are congruent. Angle, angle, side, 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 and angle, side, angle. That's what those different sets of 3 letters mean. Okay. Now looking back at some of the theorems and postulates we've looked at before, these will all be useful when we're looking over our proofs and our congruencies from now on. The one that in particular that I wanted to review is the reflexive property. That just says anything equals itself, A equals A. That one will come in handy in one of our proofs today. And right now it seems kind of like, well, duh, but you'll see when we get there why that one is so particularly important. And again, the rest of these ones will be things that come up again, and we're going to make sure that we know what's going on with those. So the first one that we're going to look at is angle, angle, side. Okay, this basically says that if we have 2 different triangles, like here we have ABC and XYZ, if we can say that 2 of the angles from one triangle and one of the sides that's not included between them. So if we had this angle here, we're not talking about the one in between them. It has to be a separate one. If those are congruent to the angle, and the side of another triangle, then those triangles are the exact same triangle. Okay? Now again, we need to make sure that we're keeping this angle, and this side, they need to be matching. Okay? So that green one has to match with this one, the blue one has to match with this one. But if I said that this side was as big as this side, we couldn't say that these triangles are congruent. Okay? Because in our first case, ABC, across from angle C, across from our green angle, that's where the red dash here, that's where the side is congruent. So we'd have to have on the other triangle across from the green angle is where the side would be. Okay, so we can't use that one. We can only say they're congruent if it's this side. Okay, as long as we have one angle, and one side, congruent to one angle, and one side, they're the exact same triangle. Okay, the other one, or another one, would be side, side, side. And again, what this is saying, if I have 2 triangles, I say this side is congruent to this side is congruent to this side, and this side is congruent to this side. These have to be, again, the exact same triangle. There's no other way to draw a triangle with the 3 sides being the same length as another triangle. So if I were to give you 3 pieces of board, or like 3 straws of different lengths, and I would tell you to make a triangle with these 3, all of the triangles you could possibly make would be the exact same triangle. Okay, they're all going to look exactly alike. They're all going to have the same angles everywhere, the same side lengths. It'll be pretty much the exact same triangle. So side, side, side. If we can prove all of these sides equal all of these sides, then we know these are the exact same triangle. The last one that we're going to look at today, angle, side, angle. Again, this is saying if I have 2 different triangles, CDE and RON, if I have this angle equal to this angle, if I have this side equal to this side, notice that that side is in between our angles, so this angle equal to this angle, then again, we know that they have to be the exact same triangle. Okay? In this case, it's different from our angle, angle, side, because the side is in between our 2 angles. But in either case, again, if I can say angle, side, angle is same to, or equal, congruent to angle, side, angle, these are the exact same triangle. Every piece on them is the exact same thing. So this angle then would be the same as this angle. This side is exactly as long as this side. This side right here is exactly as big as this side here. They have to be. So let's go over some examples of how this looks or how it'll work. Give the congruence statement and the reason that the triangles are congruent. Use corresponding parts of congruent triangles being congruent, CP-CTC, to identify the remaining corresponding parts and values. So if we look at our two triangles here, we'll notice they each have one side with 1 tick mark here and here, one with 2 here and here, and one with 3. So we need to make sure again that we'll match up all of our pieces. So the first triangle we'll call A, B, C. Well, A is the corner, or the vertex that's across from our double side line. So if we look at our other triangle, the double side line is across from R. So triangle ABC would be congruent to triangle A is in the same place as R. B is in the same place as, well, it's across from the 3 bar. So the 3 bar here is across from I, so RI. And C would be in the place of T then. So we'd say triangle ABC is congruent to triangle RIT. Remember, the order in which you say these matter. So we have to say ABC congruent to RIT. We can't say ABC congruent to IRT or something like that. We can't mix them around. They have to be in the same spot. How can we say that? How do we know that these are the exact same triangle? Well, side, side, side is congruent to side, side, side. So we'd say triangle ABC is congruent to triangle RIT by side, 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 or SSS. Moving on from there, we need to use our corresponding parts of congruent triangles to identify the remaining corresponding parts. Well, again, if all of these sides are congruent to each other, or at least it's telling us that, we know that AB equals RI, A to B, R to I, A to C is the same as R to T, and B to C is the same as I to T. So those are all of our sides being congruent to each other. Moving down, let's look at some of our angles. Angle B is in the same spot as angle I. So even though they don't tell us over here that I, or how big angle I is, we know that it has to be 66 degrees because it's the same as B. So angle B equals angle I, and they both equal 66 degrees. Same thing, angle C is in the same spot as angle T. And we know that T is 39 degrees, so C also has to be 39 degrees. So angle C equals angle T, and they both equal 39 degrees. Now A and R are in the same spot, but we don't know how big either of those are. They didn't tell us. But we can figure out pretty easily that if this is 39 and this is 66, or if this is 66 and this is 39, then we know we just have to subtract those off from 180 to find our remaining angle. So 66 plus 39 is 105. 180 minus 105 would be 75. So angle A equals angle R. They're the same size. They're congruent. And they both equal 75 degrees. So this would be all of the parts of each of these two triangles being exactly the same. For our second example, look at the picture below to answer the following questions. We have two triangles, one A, B, and C, one D, E, and F. What would we need to prove these triangles congruent using angle side angle? Well, looking at our first triangle here, we have two angles, angle C over here and angle B over here. Well, in this one, angle B had the one swoop, so we'd have to have angle E being the same as that one. F had the two swoops, so F is the same as C. So if we wanted to prove these the same or congruent by angle side angle, we would need the side in between them. Notice the side, the S is in between the two A's. So we'd have to say this side is congruent to this side. So what would we need to prove that? We would need to know that BC equals EF, that these two sides are equal to each other. They're the same length. What would we need to prove the triangle's congruent if we wanted to use angle, angle, side? So if we wanted to know again, this angle, and maybe the angle across from the red one. So we'd have to know that AB equals, again, the one across from the red, equals DE. That would be one possible way if, I guess that'd be this one over here, AB equals DE. Then we would know angle, and the side that's not included. If we wanted to use a different angle though, or a different side should I say, this angle, and the one across from the green one. We'll do that one in yellow. So we'd have to know, again, the one across from the green angle in this case. So we'd have to see that AC equals DF. So two different things would let us prove it by AAS, if AC equals DF or if AB equals DE. Either one of those would let us know that we can prove those triangles are the exact same using angle, side. Now let's say we did have all that information. If they did tell us that BC equals EF, or if they told us AC equals DF, or if they told us AB equals DE. So what would be our congruency statement for this? Well, again, we'll start with triangle ABC, going ABC. A is across from the blue side, B is across from the blue side, so D would be our first letter. B is across from the yellow side, E is across from the yellow side, so E has to be next. And C is across from the purple, and F is across from the purple. So F has to be our last one. So our congruency statement would be triangle ABC is congruent to triangle DEF. For number 4, looking at these two triangles, are these congruent? If so, by what reason? If not, why not? Well, let's take a look at these ones. Each of these has this double swoop angle being congruent to each other. Each of them has this kind of smaller green angle, or single swoop here, being congruent to each other. And they each have a side that is congruent to each other. So an angle, and a side, an angle, and a side. So first, we might be tempted to say, yes, they have to be by angle, side. But if you'll notice, in this case, our congruent side is across from the green angle. In this case, our congruent side is across from the red angle. So they don't actually match. So as you look at these, you can kind of tell that, yeah, they have the same angles here, but we can tell that this triangle is much smaller than this one. So it's a good representation of why we have to be sure that all of our pieces match up. So the side across from the angle has to match with the side across from the angle. So in this case, we would say no, the congruent parts don't match. And that's kind of further proof of that. The congruent side, so the side that we found, is across from the smaller angle in our first triangle. It's across from W here, which looks a little bit smaller than V. And it's across from the bigger angle. It's across from this angle M in the second triangle. So it doesn't actually match up. So these ones would not be congruent. We can't say this triangle is exactly the same as this one. We've got 2 examples left here. Just looking at a couple different proofs. So for number 5, if we are given this figure and we see that NQ bisects angle MNP. So this angle from M to N to P, this angle is bisected by this line right here. And they went so far as to kind of draw in then an implication of that these angles have to be the same. Now, we can't really say that yet. We have to prove that or write that down, but they already drew that in for us. We also know that angle NMQ, so NMQ, this one here, equals angle NPQ, so this one right here. And again, they already drew that in for us. So we need to prove that these triangles from M to N to Q, so this left triangle equals this triangle over here, PNQ. So everything over here, this triangle, is exactly the same as this triangle. So Looking at our statements then, we'd have to say NQ bisects angle MNP, and angle NMQ equals angle NPQ. Of course, that was all given, so our reason is just the given. Our second statement, though, we need to say that angle MNQ equals angle PNQ. From here to here to here, so this green angle right here is just as big as this green angle, PNQ. And they kind of already drew that in for us. Why can we say that, or why were they able to draw that in? Well, that's the definition of an angle bisector. Here it told us that NQ bisects that angle, so it means that this angle equals this angle. So already, if we look at our triangles, we have two different angles. The red one and the green one are equal to the red one and the green one. So it looks like we're getting there. We're most of the way there. At this point, we need to find a side that is going to be equal to each other and say why that is. So we can say that this side, Q to N, or should I say N to Q, equals N to Q. This side is exactly as big as this side itself. Why can we say that? Why do we know that? Well, this is where you'd use the reflexive property. Any line has to be just as big as itself, no matter what. So our last statement then, triangle MNQ, this triangle, is exactly as big, or the exact same triangle, as PNQ. And what let us know that? How do we know that for sure? Well, we have an angle, and a side being congruent to an angle, and a side. Even though it's literally the exact same side, it's equal to itself. So we can say by angle, side, these two triangles are the exact same triangles. So if we wanted to, we could go so far as to say this side equals this side then, because we know that they are the same triangles. We can say this side equals this side, because they're the exact same triangles. We can say this angle equals this angle, because they are the exact same triangles. All right, we have our last proof here. Given this figure, we have kind of a larger circle, and inside of the circle, looks like there are a couple lines crisscrossing each other. It looks like they make two triangles, one from M and O, and one from P to Q to O. So if we are given that MO equals PO, so this one equals this one, and that NO equals QO, so this one equals this one, we need to prove that, we need to prove that angle MNO, so MNO, this angle here, equals angle PQO. So this is the angle that we're trying to show. We don't know it yet for sure. That's what we're trying to prove is equal, or are congruent to each other. So, very first statement is always your given information. MO equals PO and NO equals QO, and that's given. Our second statement that we can say, for sure, I'm going to use black, NOM, this angle, equals QOP, this angle. Why do we know that this angle has to be as big as this angle? Well, we have two crisscrossing lines here. This angle is across from this angle, so they're vertical angles. Because these are vertical angles, we know that these are exactly as big as each other. At this point, now we have a side, an angle, and a side being congruent to a side, an angle, and a side. So I can say triangle MNO. Again, I need to make sure everything matches up. M was across from the green side, so P is across from the green side, so P to Q to O. Just making sure all my pieces match up. How can I say that those triangles are exactly the same triangles? Side, angle, side. Here's a side, here's an angle, here's a side, congruent to, here's the side, here's the angle, here's the side. Now that I know that they're the exact same triangle, I know that this side is the same as this side. I know that this angle is the same as this angle. And I know what I was trying to prove. This angle is as big as this angle. So I can say angle MNO equals PQO. Why can I say that? Why do I know for sure that those have to be just as big as each other? Well, because corresponding parts of congruent triangles are congruent. No matter what, once we've shown that they're the exact same triangle, all of those pieces are exactly the same. So make sure you just write CPCTC. Don't write out all the words. Corresponding parts of congruent triangles are congruent. And that will finish up our lesson.